Dear students, in the previous lecture, we have discussed about, we have learned property number 1, 2, 3. The property 1 says that if the rows and columns of a determinant are interchanged, the value of the determinant is unchanged. And the second one, in any determinant, any two rows or two columns are interchanged, the determinant changes its sign. Third, yes, the property 3, in any determinant, any two rows or any two columns are identical. That means corresponding elements of two rows are exactly same. Then the value of the determinant is 0. Now today we'll go for property number 4. This property number 4. I'm going here. Click here. So property 4. So the property number 4, what it indicates is also very small derivation. First, let me give some small example here. Like suppose 2, 3, 4, 0, 1, 3, 0, 0, 5. So here, what the property number 4 says that, so this is the principal diagonal. This is the principal diagonal. If any one side of the principal diagonal elements are zeros, if any one side, completely any one side of the principal diagonal elements are zeros, then the value of the determinant can be obtained by multiplying diagonal elements. The value of the determinant can be obtained by multiplying the diagonal elements. That is 2 into 1 into 5. That is 10. Any one side, it is also maybe like this also. It is suppose 4, 0, 0, 0, 5, 1. Suppose this is 0, 1, 2, 3. So here also see that this is the principal diagonal. The one side of the principal diagonal elements are totally 0. Any one side, either it is upper side or lower side. Completely, if any one side of principal diagonal elements are all zeros, then the value of the determinant directly can be obtained by multiplying the diagonal elements. That means 4 into 5 into 3. That is equal to 60. This only you have to prove now. So look at this derivation now once again. So property number 4, how we'll ask is a small derivation. Yes. Property number. In any determinant, if any one side of principal diagonal, elements are zeros. In any determinant, if any one side of principal diagonal elements are zeros, then the value of the determinant can be obtained by multiplying the diagonal elements. Multiplying the diagonal elements. So, my dear students, the proof is like this. So here, I'm going to take one determinant here. See this? Delta is equal to A1 B1 C1 0 B2 C2 0 0 C3. So here, one set of principal diagonal elements are 0 here. So the value of this first expand through R1 only. We'll see that. Already we know that the answer will be A1 into B2 into C3. Why? Because here we have taken this is A1, B1, C1, 0, B2, C2, 0, 0, C3. So in this determinant already we are aware this is the principal diagonal. We are completely one side of the principal diagonal elements are zeros. So the value of the determinant can be obtained by product of diagonal elements. That means you have to prove that A1 into B2 into C3. That is A1, B2, C3. Now expanding along R1. Expanding along R1. So therefore delta is equal to plus A1 into, so A1 means here, yes, A1 into what you can write here, B2 C3 minus 0 into C2 0. Now here you see A1 into, once again you see here, B2 C3 minus 0. So, or else now we can go for minus B1 into vertical, horizontal 0 0 plus C1 into vertical, there is a column and row in which the element C contains will be deleted. 0 minus 0, that is 0. Finally the answer will be A1 B2 C3. That is indirectly A1 is first element into B2 into C3. So therefore again we can write here A1 B2 C3. So if any one side of the principal diagonal elements are zeros, the value of the determinant can be obtained by product of diagonal elements. So this is the property number 3. Property number 4.